These small critters are embarking on a big move. Nearly 200 million red crabs are making their annual migration back to the ocean, crossing Christmas Island. The event is so large, it shuts down a number of roads.
When millions of ant slayers were unleashed on Crab Island, no one expected what happened next. Within hours, the island's rhythm changed. Something unseen was set in motion. What began as a bold experiment quickly turned into a spectacle of nature's unpredictability.
Yellow, crazy ants. When migrating red crabs march into their territory, the ants attack, squirting acid into the crabs' eyes and mouths. The crabs have no defense.
Was this the breakthrough scientists had hoped for, or a step too far in controlling the wild? As the reactions unfolded, the island revealed more than anyone anticipated. What exactly did they trigger beneath the surface of this fragile paradise? The mass release of ant slayers. Crab Island was recently the site of a massive and deliberate release of millions of ant slayers, an action that immediately disrupted the island's delicate balance. This wasn't a gradual intervention, but a dramatic and concentrated effort aimed at drastically reducing the pervasive ant population. The scale of this release was unlike any previous pest control attempt in the area, with millions of small agents deployed rapidly across key ant habitats. This sudden onslaught sparked instant reactions that quickly became impossible to ignore. Ants, typically some of the smallest and most resilient creatures, suddenly faced an overwhelming force. The island's usual buzzing activity gave way to an eerie silence as ants began to vanish from surfaces and trails. Observers initially noted patches of stillness where once there had been constant ant movement, signaling that something profound had occurred. These observations hinted at the effectiveness, but also the intensity of the intervention. But the story wasn't simply about eliminating ants. The aftermath was complicated and multifaceted, revealing hidden layers of ecological interdependence. Signs of distress appeared not only among the ants, but also in species that rely on them. The true impact was difficult to measure at first glance, raising questions about unintended consequences still unfolding beneath the surface. The timing of the release added to the tension. It coincided with critical periods in the island's seasonal cycle when ant activity is heightened. This strategic timing maximized the ant slayer's impact, but simultaneously intensified ecological shockwaves. Broader patterns of reaction began to emerge among the island's other inhabitants, hinting at deeper connections. Curiously, some ant colonies appeared baffled, showing unusual behavior like abandoning nests or ceasing their normal foraging routines. This disorganization suggested that the ant slayers affected not only survival, but also the social structure and communication within colonies. These behavioral disruptions amplified the sense that the intervention was rewriting life patterns in real time. Local researchers monitoring the site were quick to record these sudden changes using cameras and sensors. Their initial data showed a stark decline in ant numbers in treated zones compared to control areas, confirming the potency of the release. Still, the data also raised red flags about collateral effects, as insects indirectly linked to ants also showed population shifts. Media and public attention grew as images and reports of the rapid decline circulated widely. Viewers were surprised by how quickly and completely the ants seemed to vanish, challenging assumptions about pest control's limits. The scale of the release invited both intrigue and concern over what might come next. The most puzzling aspect was how little was initially understood about the full consequences. Scientists warned that this dramatic intervention was just the beginning of a complex story, one that would need careful unraveling. Questions lingered. Was this a simple success story, or the start of an ecological cascade with unknown endings? What the mass release revealed first was a snapshot of a fragile system pushed to a breaking point. From here, understanding the island's broader role in this drama required a closer look at Crab Island itself, its environment, inhabitants, and why ants matter so much. The island's unique ecosystem holds clues to why the reaction was so immediate, and why the unfolding changes matter on a grander scale. Crab Island's unique ecosystem. Crab Island is more than just a dot in the ocean. It is a complex environment teeming with life intricately woven through centuries of natural balance. The island's ecosystem is characterized by rich biodiversity, supporting plants, insects, birds, and small mammals that together form a delicate web of interdependence. Among these, ants hold a surprisingly central position, influencing nutrient cycles and food chains. These ants are not simply pests, they are ecosystem engineers. Their activities aerate soil, distribute seeds, and help control populations of other insects. On Crab Island, some ant species have co-evolved with native plants and animals, creating relationships essential for survival and regeneration. Disruptions to the ant population resonate through the ecosystem like ripples in a pond. The island itself features varied habitats, from coastal zones to dense underbrush, each hosting unique communities. The ants thrive in many of these areas, their colonies interspersed among roots and leaf litter, acting as keystone species in their respective niches. The sheer diversity of ant colonies reflects the island's evolutionary history and ecological complexity. Seabirds and larger predators rely indirectly on ants by preying on their eggs, larvae, or other species controlled by ants. Meanwhile, ants influence plant health by managing herbivorous insect populations. This intricate balance maintains the lush, vibrant environment that defines Crab Island in contrast to many degraded coastal sites globally. When ants vanish or sharply decline, noticeable shifts can occur quickly. Plants may struggle without seed dispersal, and populations of other insects can surge unchecked. This domino effect alters food availability for birds and mammals, pushing entire species into stress or adjustment. The ecosystem's dynamics underscore the ants' ecological importance beyond mere nuisance control. In addition, Crab Island is an isolated environment to a great extent, which means that the species have very slow migratory abilities and thus not very efficient adaptation abilities when it comes to such sudden changes. The ecosystem's sensitivity to such external disturbances, including the application of chemicals or the invasion, is thus very high. Therefore, the ant slayer's arrival was a risk not only in terms of numbers, but also because the island's resilience had natural limits. Local conservationists have long considered Crab Island a significant natural laboratory for the study of island ecology and species interactions. The consequences for ants, therefore, offer essential insights whose implications reach much beyond this tiny piece of land. Knowing how such a key player reacts to disturbance sets the stakes involved. Pest control on Crab Island has always been a sensitive issue in the past and has been done with great care and concern for the environment. The use of millions of ant slayers was a decision that could not only change the situation, but also create unexpected problems due to the very nature of the experiment. It was a case of weighing necessity and vulnerability against each other. Despite this, the island's ecology still speaks silently to a great experiment where the extinction of one species can lead to vast changes across the landscape. In order to understand the reason behind the disturbance made by this intervention, one needs to get a clear picture of the nature and mechanism of the ant slayers that are used. The nature of the agents unleashed holds the key to appreciating both their power and the concerns they raise. Silent weapons beneath the soil. The ant slayers released on Crab Island are sophisticated agents specifically designed to target ant populations with remarkable efficiency. These are not ordinary pesticides. Their formulation combines chemical compounds and delivery methods optimized for both speed and reach. This blend ensures they penetrate nest structures and disrupt colony functions at their core. Many of these ant slayers operate by interfering with the ants' nervous systems, incapacitating them rapidly. Others interfere with reproductive cycles or degrade critical communication chemicals inside the colony, causing disarray. Such mechanisms explain the sudden collapse of ant activity observed after deployment. The technology behind these agents reflects years of research into ant behavior and physiology. In some cases, the ant slayers include bait components that entice worker ants to carry toxins back to the nest, spreading the effect through entire colonies. This Trojan horse method magnifies their impact beyond immediate contact. Understanding this mode of action is crucial to recognizing why the population drops were so sudden and widespread. The chemical substances are carefully calibrated to be highly toxic to ants, but relatively less harmful to other insects or animals when used as directed. Yet, on a densely populated island like Crab Island, such selective toxicity is hard to guarantee fully. The concentrated release volume amplifies exposure risks across multiple species, raising environmental concerns. Biological alternatives also appear in some formulations, incorporating microorganisms or natural compounds that sabotage and survival. These bioinsecticides aim to reduce collateral damage compared to synthetic chemicals and contribute to sustainable pest management approaches. Whether the formulation used included such agents is a vital part of assessing effects on Crab Island's ecosystem. Notably, these ant slayers degrade over time, breaking down in soil and water to minimize long-term contamination. However, decomposition rates depend on environmental factors like temperature and moisture, which vary widely on Crab Island. Such variability influences how long residual effects might linger and continue to affect non-target species. Though designed to be safe when used correctly, the scale and intensity of the release meant that even trace toxicities could accumulate or interact unpredictably. This raises questions about dosage thresholds and ecological tolerance limits in island environments. Monitoring post-release has been critical to identifying emerging risks. Experts have debated the balance between the ant slayer's immediate efficacy and associated ecological trade-offs. The fine line between controlling invasive or pest ants and preserving native biodiversity often prompts difficult decisions. Crab Island's case adds a vivid example of how powerful tools can generate complex outcomes. In the end, these ant slayers represent cutting-edge pest control, but also a profound ecological gamble, one whose unfolding consequences demand careful observation and reflection as the story continues. The reactions of other species and the environment to such potent agents would reveal just how tightly interconnected Crab Island's life truly is. Immediate ecological reactions. The release of millions of ant slayers on Crab Island sent shockwaves through the local ecology, triggering sudden and unexpected changes. Almost immediately after the intervention, researchers noted a sharp decline in ant populations, but the effects rippled far beyond the vanished insects. Other invertebrates, some of which depended directly or indirectly on ants, began to show fluctuating numbers. These cascading shifts painted a picture of how tightly interwoven life on the island truly is. Flora also responded quickly to the absence of ants. Ants, as natural seed dispersers and soil aerators, play a critical role in the vitality of many plant species on Crab Island. Without them, some plants experienced difficulties in seed distribution and nutrient cycling. This instability hinted that plant regeneration cycles could be disrupted, potentially altering long-term vegetation patterns. The early signs of these changes foreshadowed wider environmental transformations yet to come. Bird populations offered another observable impact. Some seabirds and ground-nesting species feed on ants, and the insects regulated by ants, so their food sources shrank suddenly. As a result, altered feeding behaviors and movement patterns were recorded, with certain birds venturing further or changing nesting habits. These shifts underscore how the ant slayers set off a chain reaction among the island's fauna. Interestingly, a few invasive insect species took advantage of the vacuum left by the declining ants. Freed from natural ant predation and competition, these newcomers began to proliferate rapidly. This unexpected surge introduced new challenges, as invasive species can further destabilize fragile ecosystems by outcompeting natives. The unfolding scenario highlighted the complexity of ecological balance and the risks tied to sudden disruptions. Microbial communities in the soil also showed changes, responding to the altered chemistry and reduced ant activity. Since ants influence soil microbes through their movement and waste, their decline modified the microbial landscape. These changes could affect nutrient availability and soil health, demonstrating how even unseen organisms are caught in the ripple effects. The overwhelming size of the biological changes made it obvious that the ant slayers did not just slay ants, but also had a significant impact on the ecosystem. They set off a process of ecological reorganization, as species were in the very process of adapting to changes in their environment. The whole thing happened so quickly that the scientists had the rare opportunity to observe the dynamics that usually take place over a long period of years or even decades. The island, in spite of some early signs of resilience, was considered by the experts to be vulnerable to the ongoing monocultures or the gradual extinction of native species networks. The removal of ants caused the main ecological processes in the area to become uncertain, thus making the habitats more vulnerable to erosion and the invasion of foreign plants and animals. The delicate interrelations that once supported the variety of life forms on the island were now in danger. The stunning and extensive evidence that was filmed and photographed immediately after the release could be regarded as a warning and also as a call for action. It depicted the impacts of extermination not only in terms of the total death of uninvited insects, but in terms of the total transformation of ecosystems. An elaborate equilibrium had been disrupted, and its total effect was just starting to be uncovered. The living organisms of the island reacting to this drastic alteration made the human aspect unavoidable. The local community, the scientists, and environmentalists were all trying to make sense of the consequences of the introduction of such very effective ant predators in a habitat that was so sensitive and tightly linked. The island's inhabitants faced difficult questions about safety, ethics, and the future of this delicate environment. Human responses and concerns. The immediate aftermath of the Ant Slayer release prompted a wide range of reactions among those connected to Crab Island. Residents and local communities expressed mixed emotions. Relief that the persistent ant problem might finally be under control, yet unease about what the sudden silence signified. For many, the abrupt disappearance of ants felt both astonishing and unnatural, raising deep questions about the long-term health of the island they call home. Conversations spread quickly in homes, local gatherings, and online forums, revealing a public eager to understand what had truly happened beneath the surface. Environmentalists and conservation groups were among the first to raise alarms. They warned that the large-scale use of chemical agents in such a delicate ecosystem could carry heavy ecological costs. Their statements emphasized the risks of collateral damage to native insects, plants, and soil organisms, urging a shift toward sustainable, science-based management. This debate highlighted a growing tension between human control and nature's capacity for self-regulation. a reminder that every intervention, no matter how well-intentioned, has consequences. Government and environmental authorities responsible for authorizing the release faced scrutiny from all sides. Officials defended the operation as an urgent and carefully planned effort to protect the island's biodiversity from an escalating ant invasion. However, critics demanded transparency about testing, risk assessments, and long-term monitoring plans. The situation revealed the difficulty of balancing immediate action with ecological ethics and accountability. Meanwhile, scientists became crucial mediators in the unfolding dialogue. They worked to gather accurate data, interpret early patterns, and provide guidance for mitigation. Their message was clear. The dramatic first results were only the beginning of a complex ecological story, one that would require time, patience, and collective responsibility to fully understand. Public health officials also weighed in, evaluating any risks the ant slayers might pose to people living on or near Crab Island. The chemical compounds used were considered generally safe when employed correctly, but the unprecedented scale raised legitimate safety concerns. Clear communication became essential to reassure communities and dispel misinformation. Media coverage amplified the debate by sharing images and stories of the rapid ant decline and its environmental echoes. The vivid footage galvanized interest and concern worldwide, transforming a local event into an international case study. This attention added pressure on decision-makers to balance transparency with management responsibilities. Local indigenous groups contributed a vital voice, reminding stakeholders of the island's cultural and traditional significance. Their connection to the land emphasized stewardship responsibilities and the importance of respecting natural processes. Incorporating indigenous knowledge was seen as key to shaping a more holistic response. The controversy also sparked discussions about the ethics of employing such intense chemical measures in natural settings. Questions about consent, precaution, and ecological rights surfaced among policymakers and activists alike. These debates pushed the boundaries of conventional pest control ethics, framing Crab Island as a symbol of broader environmental dilemmas. Ultimately, human responses reflected both hope and apprehension. Hope that pest control would restore balance, and apprehension that the solution might create new problems. This dynamic tension illustrates the profound challenges of managing ecosystems influenced by human intervention. As these concerns unfolded, the focus naturally shifted toward understanding the longer-term risks and the island's path forward. Longer-term environmental risks. The large-scale release of ant slayers on Crab Island set off a chain of consequences that extend well beyond immediate pest control, raising concerns about the ecosystem's future resilience. One major worry is that the sharp reduction in ant populations could destabilize complex food webs, leaving gaps in nutrient cycling and soil health. Over time, these gaps could lead to decreased soil fertility, slower plant growth, and an overall decline in ecosystem productivity. The delicate balance maintained for centuries now faces unpredictable shifts. Another significant risk involves the potential for invasive species to establish stronger footholds. With ants suppressed, species usually kept in check by ant predation or competition have the opportunity to expand unchecked. This could result in new dominance by non-native insects, plants, or microorganisms that further disrupt native biodiversity. Such invasions rarely remain isolated and can permanently alter the island's ecological character. Water quality also faces possible indirect consequences. Changes in vegetation and soil structure affect runoff, sedimentation, and nutrient input into surrounding waters. Marine environments near the island rely on clean inputs to sustain coral reefs, fish populations, and other aquatic life. Altered terrestrial conditions could cascade into coastal degradation, highlighting how connected terrestrial and marine ecosystems truly are. Concerns persist about chemical residue from the ant slayers as well. Although designed to break down over time, factors like variable temperature, moisture, and soil composition influence degradation rates. Persistent residues may accumulate or interact with other environmental chemicals, with unknown effects on non-target organisms. Continuous monitoring is critical to detect subtle or delayed toxic impacts. Local scientists have observed initial signs of slowed recovery in some insect populations not directly targeted by the ant slayers. These patterns suggest possible bioaccumulation or indirect harm through the food chain. If these effects deepen, they could hinder pollination, decomposition, and other ecosystem services essential to sustaining life on the island. Climate variability is a huge factor that brings uncertainty to the situation. The weak ecosystem caused by the ant decline could be made even weaker by drought or flooding. Furthermore, the weather might inflict the same damage to the ecosystem and thus slow down the process of recovery to making it more difficult and risky. Crab Island's small area limits the possibilities for the species to either migrate or adapt to the unfavorable conditions. The inhabitants of the island are becoming increasingly worried about the issue of preserving the island's health and fertility. The old methods of obtaining food, gathering medicinal plants, and carrying out cultural activities all rely on a steady, healthy environment. Thus, if the environment were to be disturbed for a long time, the health and heritage of the community would be at risk, thus raising the social stakes of the ecological disturbance. Conservationists underline the necessity of adaptive management techniques that allow long-term monitoring and variations in responses according to the situation. Future pest control methods will have to take a hint from the current case in order to lessen the ecological impacts and encourage the resilience of ecosystems. A collaboration of scientists, locals, and government officials is crucial in building a sustainable future. The story of Crab Island speaks of an ecological fact that applies to all. One solution might lead to another problem needing the same virtues of humility and care. The island's future will not only be a carrying of the lessons learned here, but also transferring them to different places beyond its borders. Understanding these risks pushes the conversation naturally toward reflecting on the broader lessons this intervention teaches us about pest control and ecosystem care. Lessons learned from the intervention. The dramatic ant slayer release on Crab Island offers a powerful case study in the complexities of managing invasive species within sensitive ecosystems. Above all, it highlights the delicate balance between immediate pest suppression and long-term ecological health. While the intervention achieved rapid ant population declines, the resulting ripple effects revealed unintended consequences that caution against overly aggressive approaches. This balance between urgency and precaution must guide future efforts. One clear lesson is that pest control cannot be viewed in isolation. Ecosystems are intricate systems where a change in one species reverberates through many others. Effective management requires comprehensive ecological understanding and predictive modeling to anticipate such ripple effects. Ignoring these connections increases the risk of collateral damage and ecosystem destabilization. The experience also underscores the importance of scale and timing. Deploying millions of ant slayers at once amplified impacts that might have been more manageable if phased or targeted differently. Timing interventions to coincide with vulnerable points in pest life cycles must be balanced against minimizing harm to native species and ecosystem functions. In other words, precision and patience can be as important as potency. Another important takeaway is the value of integrated pest management practices. Combining chemical, biological, and cultural control methods often yields better long-term outcomes. Introducing natural predators, habitat restoration, and community engagement can reduce dependency on chemical interventions and build ecosystem resilience naturally. Crab Island's experience reinforces how multifaceted solutions are preferable to one-dimensional tactics. Transparency and public participation are identified as essential elements as well. The lively public discussions that took place after the publication showed that community viewpoints and ancient wisdom should be considered in the decision-making process. Communication that is open and honest helps to build trust and cooperation, which in turn ensures that interventions are in line with both the ecological aims and the social values. The case also highlights the changing perception of environmental stewardship ethics. It puts the different parties involved in the situation to decide between human wants for fast remedies or responsibilities to preserve intricate living systems. The precautionary principle, taking the safer route in cases where the results are not clear, gains more importance in these circumstances. The necessity of respect for ecological integrity must guide the use of technology. Monitoring and adaptive management emerge as crucial means in this case. Managers can be flexible enough to deal with new issues that arise through continual data collection, impact assessment, and readiness to change strategies. Their application on Crab Island will be a turning point in directing the recovery process and making recommendations for future interventions in other places. The concluding remark about this intervention is that it gives a global perspective on the conservation challenges faced by islands. Their separation makes them very weak, but on the other hand, they become very attractive and significant for researchers engaged in the creation of new conservation techniques. The knowledge acquired from Crab Island will not just benefit other islands confronted with the same issues, but will also act as a prompt that the demand for ecosystem management that is balanced, informed, and thoughtful is something that exists everywhere. As these insights take root, the future care of Crab Island beckons with opportunities to heal and innovate toward greater harmony. The future of Crab Island's ecosystem. The aftermath of the ant slayer release on Crab Island has begun a crucial period of recovery and reflection. Scientists, conservationists, and local communities are working to restore the fragile ecological balance that was disrupted. Their shared goal is not only to reverse visible effects, but also to understand how ecosystems react to sudden disturbances. Efforts now focus on monitoring species populations, soil and water health, and residual chemical traces to see how the environment rebounds, or if new challenges emerge. These long-term studies will offer valuable lessons on resilience, adaptation, and the limits of recovery in isolated ecosystems. Restoration emphasizes natural regeneration, allowing native plants and animals to reclaim their roles. Yet some zones require direct help, such as replanting vegetation, reintroducing pollinators, or controlling invasive species that spread after the ant collapse. These methods aim to restore harmony while respecting the island's natural processes. At the heart of this recovery is collaboration. Scientists work alongside residents, volunteers, and indigenous groups who bring generations of ecological knowledge. Their insights guide decisions, blending modern science with traditional wisdom. This partnership deepens cultural ties to the land, transforming conservation from a technical effort into a shared responsibility built on respect, understanding, and hope for Crab Island's future. Drones, satellite mapping, and environmental sensors play an equally important role in technological innovation. They allow for the early detection of stress before damage spreads by providing real-time data about temperature shifts, vegetation recovery, and wildlife activity. thus allowing for the early detection of stress before damage spreads. Technology and stewardship can coexist in the protection of fragile ecosystems as these tools reduce human intrusion while maximizing precision. An example of the harmony between technology and stewardship in protecting fragile ecosystems. Education and outreach are still the primary components of the recovery plan. Awareness programs will be conducted in which local schools, visitors, and conservation organizations will be involved. The ecological significance of the island and the lessons from the intervention will be the main focuses of such programs. This kind of interaction not only promotes an environmental responsibility culture among the people living in the area, but also makes sure that Crab Island's tale will still be told as one of the care, vigilance, and hope for the natural world. Financial and policy support continues to be critical. Sustained funding from government agencies and environmental organizations underpins long-term projects and research. Nevertheless, different policies with the Ecosystem First commitment will affect addressing land use, pest control, and tourism. The reviewers will be necessary for maintaining progress and avoiding future crises. Still, there is a little bit of uncertainty, but the early signs of recovery are giving very cautious hope. There are some native insect populations showing a rebound, and the vegetation that was suffering after the ant decline is starting to regenerate. These trends, which are positive, point to the healing ability of nature when given time and proper care. However, it will be important to remain alert and watchful to prevent the occurrence of setbacks. The saga of Crab Island is a great story that empowers other island ecosystems that are in the same plight with invasive species and human pressures to face such situations. The natural recovery process on the island emphasizes and brings to light the bottlenecks and opportunities for ecologically speaking in delicate environments. The global conservation efforts will be enlightened by the observation of this process. In the end, the island is at a threshold, the opportunity to heal and secure a one-off nature heritage, plus acquiring critical insights into man's influence over nature. The coming years will be the proving period for the applications of these lessons and the resilience of life on Crab Island. Crab Island's dramatic experiment with millions of ant slayers exposes the fragile web that ties nature together, and how even small actions can unleash unexpected consequences. It's a powerful reminder of how balance, caution, and cooperation shape the survival of our ecosystems. If this story resonated with you, don't forget to like, subscribe, and watch the next video shown on your screen for more thought-provoking explorations of our planet's most extraordinary environmental mysteries.